12.4 is about angle measures and segment lengths. Now, if you take a look at these theorems here, 12.13 and 12.14, understand where the vertex of the angle was. We've been talking about the vertex being on the circle. You take half. Well, notice the vertex is in the middle of the circle, in the circle. So I'm going to take half the sum of the two arcs. So x plus y. Notice here, it's outside the circle. So what I'm going to do is I'm going to take half of the difference of the two arcs. So that's what our cases are going to be. So in problem 1, where's the vertex of my circle, or of my angles? I'm sorry, right there, inside the circle. So x is going to equal half of 46 plus 90. Put it in your calculator, you're going to end up getting 68 degrees. Okay, well, where's the vertex of my angle? It's outside the circle now. So my angle, or z, is going to equal 1/2 of, I'm sorry, I lied. My angle is 20 degrees. So 20 is going to equal 1/2 of 95 minus z, because those are my two arcs. Okay, so what I'm going to do is go ahead and double both sides, multiply by 2, multiply by 2. I get 40 equals 95 minus z. Go ahead and subtract 95. I get negative z equals negative 55. Therefore, z equals 55. Theorem 12.15 talks about the segment lengths. The first situation, is easy. When you have two chords, it's A times B equals C times D. So each part of the segment multiplied by each other equals the other part of the segments multiplied together. Pretty simple. When you come to 2 and 3, it gets a little bit harder. You want to take what's outside, so that's W, and multiply it by the whole length, which is W plus X, equals what's outside times the whole, which is W plus Z. Okay, same thing here. What's outside, which is T, times the whole thing, which is still T. That's why it gives us T squared. And then equals the outside times the whole, which is Y times Y plus Z. So let's use an example here. We're trying to find Y. So what's outside? Well, we got 6 outside times the whole thing, which is 8 plus 6, equals what's outside of the other segment, which is 7, times 7 plus y. And again, these are secant lines. You end up with what? Well, 6 times 6 plus 8, punch in your calculator, get 84, equals, go ahead and distribute through, 49 plus 7y. Well, you just go ahead and solve, subtract 49, I get 7y equals 35, and divide by 7, so y equals 6. There's my y. Now, same thing here. Let's multiply what's outside, which is z, by the whole thing. Oh wait, the whole thing's just z again, so it's z squared, equals what's outside is 8 times the whole thing, which is 16 plus 8. I end up getting z squared equals, now just again punch down your calculator, 192. Well, let's solve for z, take the square root, z equals about 13.9.